A very good afternoon to all of you present here. Welcome to day 3 of workshop on Vedic mathematics. Are we ready for day 3? Okay, without any further ado, over to you, Avinash sir.
Everyone, I believe that you all were eagerly waiting for today's session. So if my audio and video both are clear, just put it in the chat box so that I will proceed
Yes,
further.
sir, clear.
Okay, fine. Well,
Yes, sir, visible.
okay, fine. So without further delay, we will proceed then. So as I believe you all remember the technique which I had given you yesterday. So at the end, we have started with discussing multiplication of any number with a series of nines, and we have discussed the very first case in that, and the first case was when the number of digits in the multiplicand and the number of digits in the multiplier are one and the same. I hope you remember the technique, you have not forgotten. In case if you have forgotten, just briefly I'll say. So the number of digits in the multiplicand and the number of digits in the multiplier, if they are same, so what exactly you do is you consider the multiplicand and subtract 1 from the multiplicand to obtain the left part of the answer, and to obtain the right part of the answer you consider the left part, and for the each of the digits of the left part you will subtract it from 9, and that is how you get the right part of the answer. And today we will look into case 2, where you have multiplication by series of nines. The case 2 is if the number of digits in the multiplicand is less than the number of digits in the multiplier. As an example, you can look for the question which is given there. It's pretty easy. So multiply 45 by 999. You can observe that the number of digits in the multiplicand is 2, whereas the number of digits in the multiplier are 3. Okay. So the same method follows that you have used in case 1, but only thing is there is only one change. Okay. So what you have to do is you have to convert the first number, the multiplicand, into a 3-digit number. So by now, after attending 2 sessions, I'm sure you must be familiar with how exactly to convert a single digit number into a 2-digit, and also a 2-digit number into a 3-digit. How? You have to add a 0 before the number. This is only works only for the multiplicand. So you have a 2-digit number. So convert 45 into a 3-digit number by adding a 0 before the number. Okay. And then you can follow the same procedure that I've explained you in the case of 1. But only thing is, don't ignore that 0. I know if you put 0 before the number, that doesn't have any value. But in Vedic mathematics, that also plays a role. So don't ignore that 0, and then follow the same technique that you have done in the case 1. So to obtain the left hand part of the answer, what you do, you consider the multiplicand and you subtract that multiplicand by 1. So that gives you 044, which is nothing but 44. The reason why I have asked you to write that 0 is because in case if you don't write that 0, you may go wrong in finding the right part of the answer. And how do we find the right part? If you remember case 1, you consider the left part of the answer and then you subtract each of the digits of the left part from 9. So that means even this 0 also is included in the left part. Keep that in mind. So you can do 0 minus, you can do 9 minus 0, which gives you 9, then 9 minus 4, which gives you 5, and for the last one, 9 minus 4, which gives you 5. So you get 955 as the right hand part of the answer, and 044, which you have already found it. And while writing the final answer, you can definitely ignore that 0, which is not necessary there. I hope you got the technique. Only thing is you have to insert appropriate number of zeros, and you have to make sure that the number of digits in both will remain to be same, and the same technique should be followed. But while finding the right hand part, remember that there is a 0, and even that 0 has to be subtracted from 9. So I believe you got the technique. So you can give a try with this, where you have to multiply 123 by 99999. You have it as it is 99,999. You can apply the same technique, and on applying the same technique, see how many zeros you need to add. Is my voice a bit low? I can see in the comment saying that your voice is a bit low. Y'all can hear me, right?
Yes, sir.
Yeah, it's fine. It's fine.
Okay, okay. Yeah. So you have 123. So you convert that 123 into a 5-digit number. The simple thing is you have to add two extra zeros in the beginning. And to obtain the left part, it's simple. Subtract 1 from 123. But remember that 00. Even you need not write that 00 here, but provided you should remember there are two zeros in front of a beginning of 122. Otherwise, you will go wrong in finding the right part of the answer. And then subtract each of the digits of the left part from 9. 9 minus 0 gives you 9. 9 minus 0 gives you 9. 9 minus 1 gives 8. 9 minus 2 is 7. And 9 minus 2 is 7. So you get 99877. I can see so many of them. Some of them at least have given the right answer. So your final answer that you get is 122998877. So you can give a try with these four problems. I'll give you a minute. You have the different cases there, different types. You can just give a try. You need not even work out actually. Just by looking at the numbers, you can write the product in the chat box, but write all the four answers together. Okay. So I'll give you a minute of time to solve that. See that the multiplicand has less number of digits than the multiplier. So convert the multiplicand by adding zeros in the beginning of the number so that the number of digits in the multiplicand and in the multiplier will remain to be the same. I'll give few more seconds for all those who are trying. I can see Lionel has given answer for all of them. That's great to know that so many are trying and giving the answers in the chat box. I'll give few seconds for those who are still trying. Yeah. We will begin with the first one. You have to multiply 65 by 999. So convert that 65 into a three-digit number because the multiplier is a three-digit number. So you can just write it as 065 multiplied by 999. And to obtain the left part, subtract 1. So you get 064. And to obtain the right part, consider 064. So you have to consider the left part of the answer to obtain the right part. So subtract each of the digits of 064 from 9. So 9 minus 0 gives you 9, 9 minus 6 gives you 3, and 9 minus 4 gives you 5. So you can avoid writing, however, you can avoid writing that 0 when you write the final answer. But don't forget, while finding the right part of the answer, so in the left part, 0 is also included. In the same way for the next question, where you have to multiply by 162 by 99,999, you have to add two zeros there and subtract 1 from the multiplicand, that gives you 00161, and subtract each of the digits of the left part from 9. So that gives you 99838. So you get the final answer to be 161,99838. The next one, you had to multiply 888 by, there were so many nines. So let's not waste time in counting the 9, but we'll find the answer. You just have to subtract 1, which gives you the left part of the answer, 000887. And to obtain the right part, you have to subtract each of the digits from 9. So that gives you 999,112. And in the same way for the last one, and here that the chances that that you make mistakes are more. Whenever the number is ending with 0, you may simply write that you will subtract one, you may write it as 1019 as the left part. No, that is not the way. So suppose the tip what I'm giving you, most of them have done it correctly, I believe. So the tip what I give you is, if the number is ending with 0, so just consider the last two numbers in order to avoid confusion. So 01010 minus 1 gives you 01009, and from each of the digits of left part, you have to subtract 9 from each of the digits of the left part. So you get 9 minus 0 is 9, 9 minus 1 is 8, 9 minus 0 is 9, 9 minus 0 is 9, and 9 minus 9, that gives you 0. So you get 100,998,990. I know it's pretty difficult to read out the answer, but it's not difficult to find the product. That is what is important here, because within fraction of seconds, and I'm sure the time that you are taking to solve, time that you're taking to find the product of these numbers, day by day the time is reduced, where your speed has increased, and yesterday you might have taken about 10 seconds, and today you are doing it within 5 seconds, and that's for sure. Okay, so now we will look for the third case, case 3, if the number of digits in the multiplicand is more than the number of digits in the multiplier. So here the method is slightly different. The method is slightly different, but it is not difficult. It is easy. So before I tell the method, let me tell the logic that we are actually applying over here. Okay. So let's understand the base, and I believe you all remember what we call as the base. I have done it in the last class. The powers of 10, we call it as the base. It can be 10 to the power 0, 10 to the power 1, 10 to the power 2, with a 1, 10, 100, 1000, 10,000, then 1 lakh, 10 lakhs, 1 crore. So all of them we call them as the standard base. And with respect to the base, we are proceeding to find the product. Okay. So basically, this method here, what you're doing is it just you're just finding the difference here, not the product. Even though you have to find the product, you're just making use of subtraction method and little bit of multiplication in order to find the product if you have to multiply 654 with 99. So I'll tell the logic first, and then I'll go with the shortcut, how exactly you can apply that logic to find the product of these two numbers. So first you consider the second number, which we call it as the multiplier, and identify the nearest base to the multiplier. So you have 99, and the nearest base to the multiplier 99 is 100. And how can we write 99 in terms of 100? We can just write it as 100 minus 1. That gives us 99. As an example, if I consider 999 to be the multiplier, so what will be the base? If 999 is the multiplier, the base will be 1000, and 999 can be written as 1000 minus 1. The same thing applies here. 99, I'm writing it as 100 minus 1, and instead of multiplying 654 with 99, I'm multiplying it by 100 minus 1. So I'm multiplying 654 by 100 minus 1, and this multiplication is easy. Okay, it may look little complicated because at the end of the method, because there are so many steps here. So you can multiply any number by 100 easily. You just have to put the number of zeros that are present there. So 65400, and 654 minus 1 gives you 654. And then you can make use of the subtraction method. And remember, you can't make use of all from 9 and last from 10 here. It's a specific technique, as I told you. But the normal subtraction method, what you have learned, definitely you can make use of it. And when you find out the difference comes out to be 64746. Okay, and that itself is the answer when you multiply 654 with 99. I know the method looks too much, but I'll make it very simple for you all. Okay, I've just told you the logic behind the method, and let me give you the shortcut how exactly we can apply this method. So what exactly we do is, first we have to multiply. You just have to worry about the multiplicand and the nearest base to the multiplier. You multiply the multiplicand with the base, and then you subtract it with the same multiplicand. Okay, so we will go with the same question with the shortcut. So if you have to multiply 654 with 99, you can just think what is the base for 99? It is 100. So you multiply the given number by 100, 654 into 100, that gives you 65400. And then you can do just minus 654. And subtraction, you all know it. You can do the subtraction. And once you subtract, you will get the answer as 64746. Let me make it more simple in the next question. Okay. So I believe you got the idea how exactly it works. Suppose you have to multiply 2564 with 999. So now what we will do is we will avoid writing this. Without writing this, just by doing this in the mind, we will just do the subtraction part. Okay. And you know what is the base for 999? The base for 999 is, it is 1000. So what you have to do is you have to multiply the given number by 1000. And 1000 has 3 zeros. So you just have to include 3 zeros at the end of the multiplicand. So what happens in that case? You get 2564000, and then you have to subtract with the multiplicand itself 2564. So you can do the subtraction easily, and when you subtract, you get 2561436 as the answer. You can actually avoid doing this, and only the final part can be done just by looking at the method. I hope you got the method, and I want you to try the next one. In case if you are having any doubt, you can just let me know. If not, I'll proceed with the next question. Okay, so I believe you all don't have any doubt. So you can try with the first one. It's simple. Just multiply with the nearest base and find the difference with the multiplicand. So I'm looking for your answer in the chat box. And definitely you need a piece of paper and a pen now to work out. You can try both the questions, those who have finished with the first one. Okay, that's great to know. So Lionel, then Mohit, Apthi, Rinsi, Jane are giving the answers. I want even others to try. Give a try. I'll give you seconds of time for those who are trying. In case if all from 9 and last from 10 works, as I said, the two conditions, if the two conditions are satisfied, definitely you can even try with that. Suppose if it works. I'll give few more seconds for those who are still trying. Yeah. So for the first one, where you have to multiply 7654 with 99, the nearest base is 100. So multiply the multiplicand by 100. The number will reduce to number will become 765400. Then subtract minus 7654, and the difference that you get is 757746. Okay. And in the same way, you can even try the next one where you have to multiply 10684 with 999. So the nearest base for 999 is, it is 1000. So multiply the multiplicand, the first number, with 1000. If you multiply with 1000, you get 10684 triple zeros. Then subtract, you have to do minus 10684. And the difference, it would take little time, I know that. So you will get the answer as 10673316. I can see some of them have even, yeah. So those who have given the answers in the chat box, they're all right. Okay, that's good. So now let's see how much you remember the three different cases. So identify which case it is, and then you can solve. Okay, identify which case it is. The three different cases. First one, the multiplicand and multiplier are having the same number of digits. The second case was multiplicand is having less and the multiplier is having little more number of digits. And the third one is the reverse way. multiplicand is having more number of digits and multiplier is having less number of digits. And give a try to these 5 questions and see how quickly you can recall the 3 different methods that you have learned and you can get the answer. I'll give you 2 to 3 minutes of time to solve this. There are 5 questions. I can see so many of them are trying. That's wonderful. Good. So I'll give 1 more minute for all those who are trying. Okay, so Rahul has given answers for all the 4 questions. Okay, he's given for 4. Okay, good. So it would be great if you put the answers together. Okay, so Ashok sir has given the answer for all 5. Even others can give a try. Okay, so we'll briefly discuss the methods. I know you're thorough with the method. I'll just mention the case and then the answer. The first question, 789 multiplied by 99. It's case 3 where you have the less number of digits in the multiplier. So you have to multiply by the required base. Base is 100, then subtract. You get the answer as 78111. And second question, 534 multiplied by 999. You have both multiplicand and multiplier to have the same number of digits. It's 3 itself. So you can apply the first technique what I had given you, case 1. So multiplicand minus 1, that gives you 533. And for each of the digits of the multiplicand, you have to subtract them from 9. So that gives you 466. So you get the answer as 533466. Third one, 1234 multiplied by 99999. So it comes in case 2 where the number of digits in the multiplicand are less and in the multiplier are more. You have to convert the first number 2 in such a way that it is having the same number of digits than that of the second one. You will have to add 10 there, and you can use the same technique, subtracting 1 from the multiplicand, and then from the left part of the answer, each of the digits should be subtracted from 9. So you get the answer as 123398766. The next question, 2576 multiplied by 999. It is case 3. The number of digits in the multiplier are less there. The base for 999, it is 1000. So you'll have to multiply by 1000 to the multiplicand and then subtract it. So you get 2573424 as the answer. And the last question, 8778 multiplied by 9999. So it's a case 1. Both multiplicand as well as multiplier are having the same number of digits. So you can subtract 1 from the multiplicand. You get 8777. And to obtain the right part of the answer, subtract each of the digits of the multiplicand from 9. So the final answer that you get is 8777122. So definitely you wouldn't have taken you have not even taken more than 5 minutes to solve the 5 questions. I'm sure about it. Okay. Even in case if you go back to the chat, you can have a look at it. So what time the students have started giving the answers. Okay, so with this we complete multiplication by series of nines. And definitely if you come across such situation in the future where you have to multiply, it's better to stop using the calculator, and definitely you can try with this trick. So now uh, we are proceeding to the next topic, that is finding cube roots. So what is the normal method that you use in order to find the cube roots? You can put it in the chat box. Not calculator. I know you'll get the answer in the calculator very quick. Except the calculator, what is the normal method that you use? Thrice multiplication. Thrice multiplication is to find the cube. I'm asking about cube root. Okay, so I can see various methods in the chat box. You must be familiar with the factorization method. Okay, it's called as factorization method. You write something like this. Okay, that is not called as LCM method. Some people have the habit of calling it as LCM. That is called as factorization. LCM is only when you have two or more than two numbers and then you are finding the factors. So you use factorization method in order to find the cube root, and definitely based on the number, if you start your factorization method over here, so at the end when you find the cube root, you may reach at the end of your page also. So even that is there. But in today's session, I'm going to give you a unique technique to find the cube root of a given number, and definitely you can make use of this technique to find the cube root of a given number. The technique is very simple, but before we proceed to the technique, something that is more important is basics. So only if you're thorough with the basics, the technique will work easily. Okay, so I'll teach you the basics and also give you enough time to remember the basics, and only then we will proceed with the method. Because if we go directly to the method, if we are not thorough with the basics, definitely the method, the learning that method will be a waste. I don't want that to happen. So before we will begin with the basics, and I believe that you all know the meaning of cubing a number. So cubing a number means you have a number, you're multiplying it by itself for three times. As an example, for 2 cube, it is 2 into 2 into 2, which is 8. So 1 cube, it is simple. You get 1 itself. 2 cube, 2 into 2 into 2, which is 8. For 3 cube, you get 27. For 4 cube, you get 64. And 5 cube, 5 into 5 into 5, 125. So in case if you don't remember these, please remember it, because this will be very helpful in understanding the method. So I'll give you about 30 seconds just to remember, and I'm sure because the first five cubes, everyone knows it. So 1 cube is 1, 2 cube is 8, then 3 cube is 27, 4 cube is 64, and 5 cube is 125. In the same way, remember these 6 cube, 7 cube, 8 cube, as well as 9 cube. Just 10 values you have to remember, and the first five values are simple. I know you all must have remembered this in your high school life. At the same time, you might have forgotten, but now you try to remember this, because only if you remember this, the method will be easy to understand. Okay, so I'll display all of them again. I'll give 1 minute of time. Try to remember and be thorough with that, and it would be great if you just practice writing it without seeing from 1 cube to 10 cube. Trust me, the method will be easy only if you remember this. I'll give you a minute of time. Give more importance in remembering the cubes from 6 to 10. Okay, the first five are very simple and you know it, and you can easily find even by multiplying also. But whereas when it comes to 6 to 10, you can multiply, but it will take time. So it would be great if you say a done in the chat box so that I can proceed. If you remember all the cubes from 1 to 10. I would like to see at least some response in the chat box, replies in the chat box, so that it will be easy for me also to explain you all the method to find the cube root. So now you remember the cubes. Try to remember only the second column, 1, 8, 27, 64, 125, 216, then 343, 512, 329, and 1000. And cube root is something which you have already learned it. Just the definition is what number if you cube, you get that as the answer. Okay. And how you have learned something about perfect square. And these numbers which you have, we call them as perfect cubes, or simply we will refer them as cube. Okay. So these numbers are cubes. On the other side, what number if we cube, we get these as the answer, we will be calling them as cube root henceforth. Okay. So just try to remember the cubes as well as the their cube roots. So you have 1, 8, 27, 64, then 125, 216, 343, 512, 729, and 1000. I'm stressing on asking you to learn it because it's very important. So try to remember the cubes from 5 to 10. That would be good. 5 cube is 125. 6 cube is 216, 7 cube is 343, 8 cube is 512, 9 cube is 729, and 10 cube is 1000. I believe that you all are ready with that. Okay. So this is one important thing that you need to remember. The second one, so let me go with this table. You can check the table. So I have the same table I have written in the previous slide, the table which you have seen. The second table which you have seen, the same table I have written in the other way. So just give me a minute, it's not working. Give me some time. Okay. The table which I had given you in the previous slide, this table, I've just written it horizontally, this table. Okay. So I've written the cube roots of each of the number, and I've also written their cubes. Okay. The number 1 to 9, 1 to 10, we will just refer it as a cube root, and their cubes I've written it on the second row. Okay. So, and I've also underlined the units digit of each of the cube numbers. So for this, it is 1. In the same way, for this particular number, its units digit is 9. So we will have to make a table now based on the last digit of the cube. So note that the cubes have written it in the second row. The second row represents the cube, and have written the numbers from 1 to 9 as well as 0, including 0. I've written the numbers. So the first column represents the last digit of the cube, whereas we have to fill the last digit of the cube root in the second column. Okay. So we will go with the first value here. So you have to see, first you have to see the row where there are cubes, then corresponding entry in the cube root, you will have to look for it. So the last digit of the cube. So we will see where you have the cubes ending with 1. You have to look for this row. So you have number 1, this is a cube which is ending with 1. Okay, in other words, the last digit is 1. So what about its cube root? You go for the number, even that is also having the last digit to be 1 itself. We have just written from 1 to 10 here. The same thing applies even for the above number from 11 to 20 and so on. Okay. So if the last digit of the cube is 2, you see where do you have the cube ending with 2 in the table. So you can see that this number. So 512 is ending with 2. You see its cube root. What is its cube root? Its cube root is having the digit to be 8. Okay. There is only one digit, that is 8. We will write it here. So then go for the next one where you have the cube ending with 3. Okay. So you can see 343 is ending with 3, and find out its cube root. If the last digit of the cube is 3, the cube root is having 7 as the units digit. Then go for 4. You see where do you have a number ending with 4? It is 64, and its cube root is 4. Then go for 5. So you have 125 which is ending with 5, and its cube root is 5. For 6, 216. So its cube root is ending with 6. Then for 7, you see where do you have a number which is ending with 7? horizontally across cube. Okay, that is 27. And for 27, the cube root is ending with 3. Okay, whenever the last digit is 7, the cube root will end with 3. Then for 8, you can just see where do you have the number which is ending with 8. Yeah, you have 8, only 8 there. If the cube is having 8 as its last digit, its cube root will have 2 as its last digit, the units digit. So for 8 it is 2. And for 9, you have 729. Okay, when I say 9, don't look for this 9, whereas you have to see for the 9 which is across cube. Okay, last digit of the cube is 729. And see for the cube root is its corresponding cube root is ending with 9. And for 0, you have number 1000 here. 1000 is ending with 0. So the cube root is having 0 as its units digit. I'm stressing only on the units digit here. Okay, and this is the second thing. And the last thing you have to remember in order to find out the cube root of a given number easily. Okay, so try to remember the last digit of the cube and the last digit of the cube root. The only thing is you have work in remembering the digits which are above the yellow color background, that is 2, 3, 7 and 8. Okay, so for us all the numbers it's the same. So whenever the cube is ending with 2, cube root ends with 8. In the same way, if the cube is ending with 8, cube root ends with 2. Okay, try to remember this. At the same time, if the cube is ending with 3, cube root ends with 7. If the cube is ending with 7, cube root ends with 3. And for other numbers, it's easy. If the cube is ending with 1, cube root also ends with 1. If it is 4, even the other one will end with 4. For 5, 6, 9 as well as 0, it's the same. So you have only work. In other words, you just have work to remember only these two pairs, so that the other two pairs you can easily remember. Okay. So try to remember this. And once you remember, just put a done or you're ready in the chat box so that I'll understand that you're done, because this is also very important in order to understand the method. Okay, that's great to know that somehow very quick. I'll give 30 seconds of time, those who are still trying to understand. So if the cubes are ending with 1, 4, 5, 6, 9 and 0, the cube root also ends with the same digit. Whereas for the other number, it will change. If it is a 2, then it ends with 8. If cube ends with 8, cube root ends with 2. If it is 3, cube root ends with 7. If the cube is ending with 7, the cube root ends with 3. And I believe that looking at your duns in the chat box, I believe you all are ready. So we will go with the first question, and it's very easy. Okay, so finding the cube roots of a given number. Okay, so you can look for the first question which I have displayed there. So find the cube root of 205,379. So you're actually mean to find cube root of 2. You have that symbol, but however, we need not worry about the symbol here. If you make use of prime factorization method, definitely if you start writing it over here, you will reach the bottom of the page, that is for sure. So basically here what we are going to do is we are considering the entire number first, and then we are starting to group the number into two parts. We are starting to group the number into two parts in such a way that we are starting to group from the units digit. So from the units digit, the first group should have 3 digit. Okay, and the remaining digits you can take it as separately. Whether the remaining digits can be a 3 digit number, or even if it contains a 4 digit number also doesn't matter, just keep it as a separate group. Okay, so first from the units digit you have to start grouping. So 379 will be a first part, and the other one will be a second part. So you have, what you have to do is you look for the number 379. Okay, or you can even see the entire number which is given. You see that the cube is ending with 9. So you can try to recall, if the cube is ending with 9, what about the cube root? So the cube root also ends with 9. So your right part will be, if the looking at the based on the units digit of the given cube, its cube root you have to predict. So here the given number is ending with 9. So cube root also ends with 9. Now the task is in obtaining the left part of the answer. To obtain the left part of the answer, you have another part of the given number, right? 205. you look for the number 205 in the table. Okay, where exactly 205 lies under the cube column? You can see it is lying in between 216 and 301 minutes. It's lying in between 125 and 216. It's lying in between 125 and 216. And 125 is cube of what? 125 is 5 cube and 216 is 6 cube. So between 5 and 6, you just have to consider 5 and 6. Between 5 and 60, which is lesser, and that is 5. So 5 will be the left part of the answer. So you have already obtained the right part, you have already obtained the left part. So combine them, that gives you 59, which is the cube root of 205379. So you just have little work in identifying where it lies, provided if you learn the cube of a given number. Okay. So we will work out one more. So if you have to find the cube root of 681472, those who have understood the method, you can definitely put your answers in the chat box. You can note that the given number is ending with 2. Okay. So before you make the partition itself, you can definitely get the right hand part there. So the given number is ending with 2. Whenever the given number ends with 2, you know that its cube root will end with 8. Okay. So let's make the partition of the given number. From the units digit, you have to group 3 digits as the first part and the remaining digits together. So to obtain the right part of the answer, given number ends with 2, so cube root ends with 8. And to obtain the left part of the answer, you have 681. See, where do you have? 681 lies in between which two cube numbers? That is 512 and 729. Okay. So you have 512, then comes 681, then comes 729. I can see most of them have given the right answer. And 512 is cube of what? It is 8 cube, whereas 792 is 9 cube. So you have between 8 cube and 9 cube. Among 8 and 9, 8 is smaller. So you write 8 there, so you get 88 as the answer. Isn't it easy now? You don't have to do prime factorization method. Only thing is the two important basic topic you have to remember in order to get the answer. Okay, so I believe you all understood the method. So I'm going for the next question now, and I'm not going to display the table. Okay, so let's see who is quick enough to give the answer for the third question. You have to find the cube root of 830584. Okay, so Nachit is quick enough to give the answer. That's wonderful. Even Likita. Okay, so I'll give few more seconds. You don't even need 3 seconds of time actually. So just by looking at the number, you can predict the cube root. So however, okay, let's go with it. So you can take it as 830 and 584. So cube is ending with 4. So cube root also should end with 4. And 830 is in between. Which are the two numbers? It's in between 729 and 1000. That is between 9 cube and 10 cube. And you know that 9 is smaller. So you can write there 9 as the left part of the answer. And your answer is 94. Okay. So the cube root of 830584 is 94. Okay, let's go with the next question where you have to find the cube root of 2197. It's very small number and it's easy. I'll give some time. You can think about it. I can see very few right answers in the chat box. Whereas those who have joined in other link, they're giving the right answer. Okay, that's lovely. Okay, I'll give few more seconds for those who are still trying. Okay, so you will have to split it as into two parts. So right from the units digit, 3 digits together, 197, and 2 will be separate. The given cube is ending with 7. And as I said, whenever the cube is ending with 7, the cube root should end with 3. Okay, so your right part of the answer is 3. Whereas to obtain the left part of the answer, you consider the remaining part. Okay, where you have split the given number. You have 2, and 2 is lying in between which two numbers? It's between 1 cube and 2 cube. So between 1 and 8. So 1 is smaller, So you get 1 as the answer there. That gives you 13, and cube root of 2197 is 13. In other words, 13 cube is 2197. Okay, so I'll give one more. Next question. Okay, so the number may look bigger, but you can definitely find it easily. I'll give some time for you all. You can give a try. Okay, I can see the right answers in the chat box. Even others, give a try. Okay, so even here it's the same. Just remember you have to split the given number into only into two parts. Okay, and only while considering the first part you have to make it as a three-digit number, whereas in the remaining number, even if it contains a four-digit or five-digit, just keep it as it is. Okay, so only in the first part, first group from the units digit, you have to make a group of three numbers. So you can split it as 1157 as a one group and 625 as a separate group. And you can see that the given number is ending with 5. So definitely cube root also ends with 5. You remember the given table. And for the next one, you have 1157. It is lying in between which two numbers? Okay, so you know that 10 cube is 1000, and you may have little trouble in finding 11 cube. That's all. So, and it's evident that definitely it's lying in between 10 cube and the next one, because it's just 1157, and 10 itself is smaller, so you can write 10 there. So you get 105 as the cube root of 1157625 as the answer. Okay, so answer is you get 105, which is the cube root for the given number. So now I'm going to give you a one last question. Okay, and the question is displayed. You have to find the cube root of 1404928. Okay, Lakshmi, Nachit, Joshua are quick enough to give the answer. Okay, good. Yeah, you can actually use the same method even for the larger number, but provided you need to remember all the cubes, even if it is a 13 cube, 14 cube, 15 cube, you have to remember the remaining cubes, only then the method will work. But in the real life situation, and this is a number where you have it's something about 14 lakhs 4928. So definitely if you remember up to 14 cube or even up to 11 cube, that is more than enough, because in real life situation no one is going to ask you the cube root of much bigger number than this, but however the trick will work. Okay, so the given number is ending with 8, and you just have to remember there 11 cube and 12 cube. Okay, and if you don't remember, you can definitely find the answer, since you know the squares of 11 as well as 12. So you can take the given number as 1404 and 928 as the two separate groups, and you know that 928 is the given number is ending with 8, so cube root should end with 2. So the right part of the answer is 2, and only task is remaining in finding the left part of the answer. And you have 1404 there. So 1404, and it's evident it's more than 10. So you just have to find 11 cube and 12 cube. So 1404, it's lying in between 1331 and 1728, which is 11 cube and 12 cube. And 11 cube is smaller. 11 is smaller, in other words. So 11 will be the left part of the answer. And 2 you have already got as the right part of the answer. So the cube root of 1404928, you get it as 112. Definitely you have not taken more than 5 seconds of time to find the cube root. Suppose you had used a factorization method, definitely it would take at least 1 minute or something. Okay. Yeah. That's all for today. So that's the last part of the today's topic. So in case if you are having any doubt, definitely you can ask. And at the same time, I want to mention two things. And this method what I have shown, it will work only if the given number is a perfect cube. only if the given number is a perfect cube, as in the case you have 1, 8, 27, 64, and so on. A cube of a number, only in that case it will work if it's a perfect cube. If it is not a perfect cube, the method will not work. And also, this method is included even in the curriculum now. In the state textbooks, even in the CBSE textbook, the method is included there. But only thing is, unfortunately, the method is not given more importance. Still, the textbooks are, the board is reliant on more depending on the traditional method that we used to follow, that is prime factorization method, that is given more importance than this. Yeah. So with that, I will stop the session. In case if you're having any doubt, you can ask.